Hello everybody. This is Unit 3 Constructions Day 9. Okay, so today we're going to be talking about finding the altitude of a triangle. Okay, so in geometry, the altitude of a triangle is a line segment through a vertex and perpendicular to a line containing the base. This line containing the base, this line containing the opposite side is called the extended base of the altitude, and the intersection of the extended base and the altitude is called the foot of the altitude. Okay, so blah, 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 all that fancy stuff. Basically, we're looking at these two pictures here. Okay, your altitude can either be measured on the inside of the triangle, on the outside, okay, or if you recall, your right triangles, okay, whoops, I mean do that. Your right triangles, come on, here we go. All right, your right triangles, your height is always either this side here or this side here. Again, how do we know? Because, well, these two sides are perpendicular to each other, okay? So therefore, either one of those can be used as the height, okay? So just keep that in mind for down the road here. So anyway, actually, you know what? I'll just leave that one right in there. Okay? So it can either be one side or the other, but it has to be the altitude of the triangle is a line segment from the vertex that is perpendicular to the opposite side. So as you can see here, the side's kind of extended, right? But B is perpendicular to this line segment AC. And then again, BD is perpendicular to line segment AC over here. And how do we know? Big old square letting us know it's a right angle. Okay, so let's continue on here. So again, right, your altitude can also be measured from any vertex, really. Okay, so typically you try to decide which vertex would be the easiest, right? But you can use any vertex you would like. Okay, so just keep that in mind. But as you can see in all three of these cases, that vertex down to that other side always creates a 90-degree angle, letting us know that those two lines are perpendicular. Okay? So, today's lesson, we're going to be talking about the orthocenter. Okay? So, what is the orthocenter? The orthocenter of a triangle is the intersection of the triangle's three altitudes. Okay? So, what that means is, right, is we got a line segment, looks like CF, right? This guy is perpendicular to this line segment down here coming from the C vertex. Right, so there is one perpendicular line, or altitude. Right, here's another perpendicular line. Now again, these aren't bisecting, okay? These are just the altitudes of your triangle, or another fancy word for that is your height. Okay, remember altitude and height are the same thing when we're talking about triangles, right? So triangle has three altitudes that meet at the orthocenter. Okay, so sometimes that orthocenter can be inside the triangle, and sometimes that orthocenter can be on the outside of the triangle. Okay, so not always does that our perpendicular lines, our heights, okay, our altitudes, not always do they actually meet inside the triangle, okay? So that's what the orthocenter is. It's just where all three altitudes or heights of the triangles meet, okay? So before we can talk about finding the orthocenter, we got to make sure we are comfortable with finding the height of each of our triangles, okay? So take a look at this one right here. Find the altitude of the following triangles. Well here, okay, I had to put in there, this is the right triangle, okay? So we could use either height, right? I'm going to use this one over here, okay? But we could use this one down here as well, right? Because this line is definitely perpendicular to BC, okay? So our heights, or our altitudes, okay, can be, well in this case, let's see, 1, 2, 3, 4, 5, 6, 7. Or 1, 2, 3, 4, or 18. Okay, or if we wanted to, okay, we could try to construct a perpendicular line from C down to this guy here, right? As you can see, it's not going to be a perfect spot. And again, you're always trying to go for what is the easiest, right? Don't try to beat yourself up over. Now, if they told us to find the altitude, okay, from C to line segment AB, then yes, we would have to do that. We'd have to come up with a perpendicular line going through this point C, okay? But it's not asking us to, so find the easiest altitude that you can. So that's what we're doing here, okay? So on this one, it's 7 or 18. Okay, down here, again, okay, we could extend this out, right, and find a perpendicular line. It's going to come out straight. There we go. Okay, we could use that as an altitude, right? Okay, seems like a lot of work. Okay, we could use this one as an altitude, right? We could try to find the equation of that line segment from C that is perpendicular to BA, okay? But again, what's the easiest altitude we can find here? Well, I would utilize the altitude next to this line segment BC, okay? So I'm going to extend this line out, this AC. Okay, so there's our extended line. All right, and then now we have a perpendicular line with AC. Okay, so this would be the easiest height I would choose, right? So I'd go 1, 2, 3, 4, 5, 6, 7. So our altitude is just 7 units, okay? Again, we're just going for the easiest one we could come up with. All right, now this one, our altitude is going to be inside. And I'm going to start with B. I'm going to go all the way down to that line segment AC. Okay, now again, this almost looks like a right triangle. So maybe this is another height here as well, right? Problem with that, though, is we would have to prove that that is a right angle. Okay, we'd have to make sure that that AB is perpendicular to BC, and then we would also have to use the distance formula. Okay, again, totally possible, but sounds like a lot of work. So what's the easiest height we can come up with? All right. Well, this one right here. Right. Let's go from B, right, and create a perpendicular line with AC, which we did. So now we can count 1, 2, 3, 4, 5, 6, 7. So the altitude is 7 units. Okay. So now, all right, unfortunately, it's giving us a little instruction here, right? What's it saying? It says find the altitude of the following triangle using vertex B in line segment AC. Okay, so what we're going to have to do is we're going to have to create, right up to the side, a perpendicular line. Okay, that's going to have to go through B and perpendicular, whoops, to line segment AC. Okay, so that's our goal. We're going to have to create a perpendicular line through B, right, and perpendicular to line segment AC. Okay, so the first thing we're going to have to do is we've got to find the slope of AC. Right, now we could utilize this formula right here, y2 minus y1, or x2 minus x1. Okay, or what I'm going to do is I'm going to count. See all these nice points right here where that falls right back on that grid line again? Okay, I'm going to count that slope. So I'm going to go down 2 over 3, down 2 over 3, down 2 over 3, down 2 over 3. So I'm assuming my slope has to be down 2 over 3. but I'm not totally convinced, and I want to convince you guys. So I'm going to utilize these points right here. So this is going to be negative 9 comma 0, and this is going to be 3 comma negative 8. And I should get this guy right here. All right, so let's see. So this is x1, y1, x2, y2. Okay, so I'm going to go negative 8 minus 0 over 3 minus negative 9. All right, so I get a negative 8 over, that's going to be 3 plus 9. It's going to be 12. And divide each of those by 4, and I get a negative 2/3. Okay, so I'm convinced. All right, so you can utilize that trick, but just know where your slope is coming from. Okay, so now I need to create a perpendicular line. Okay, that's going to be the slope is going to be the negative reciprocal of that negative 2/3. Okay, so let's finish it out here. All right, so here's our I'll just call it the old slope, right? Our old slope is negative 2/3. Okay, so our new slope, or what we need, okay, is going to have to be a positive 3 over 2. And then what point are we going to use? We're going to use the point B, which is negative 2 comma 4. Okay, so we got to figure out, all right, where this equation is intersecting. Okay, we're trying to come up with the equation of this altitude. That's what we're trying to do here. Okay, so once we have that equation, we can see where the intersection point is, and then we can figure out that altitude. Okay, so here's our new equation. It's going to be y minus y1 is equal to 3/2 x minus x1, which is a negative 2. Okay, so I'm going to simplify all that. So we get y minus 4 is equal to 3/2 x. Let's see, so excuse me. So remember, this turns into a positive 2. All right, and so when you distribute that, 3 times 2 is 6. 6 divided by 2 is 3. And finally, bring over that 4. So y is equal to 3/2 x plus 7. So that's the equation of the line that's going to be perpendicular to AC, okay, going through point B. So let's draw that. Oh boy, can't see our... Well, we're going through point B, so I guess we're not going to be able to utilize that y-intercept crap. But we can still do the slope. Okay, so instead of going up 3 over 2, I'm going down 3, back 2. Down 3, back 2. Okay, down 3, back 2, down 3, back 2. Okay, so here's the equation of that line segment. Okay, so I'm going to have to shrink up some of this stuff here. Whoops. Okay, in order to solve this one out. All right, so there is our equation of our line that is perpendicular to AC that goes through point B. Okay, so now let me highlight it in red. This distance here, okay, is our altitude. All right, creates a perpendicular line there. All right, so now all we got to do is just use this intersection point, use our point for B, which is negative 2 comma 4, right? And utilizing the distance formula, we can find that altitude. So D is equal to square root x2 minus x1 squared plus y2 minus y1 squared. All right, so I'm going to make this point, what's this point right here? This is -6, comma, -2. So this is going to be x1, y1, x2, y2. So x2 is -6 minus x1, which will give me a +2 squared, plus y2, which is -2, minus y1, which is 4 squared. All right, so 6 plus 2 will give me a -4 squared, plus -2 minus 4 will give me a -6 squared. And so we get (16 plus 36), which is equal to the square root of 52. And so finally, our altitude is 7.21. Okay, or you can leave it square root 52. Okay? All right. So anyway, we'll do number 5 in class. Okay, so just know that we'll do that one in class. Okay. Actually, you know what? We got time. Oof. It's running awful close here. Yeah. So we'll do this one in class. Okay. So anyway, hopefully this helps you guys with the altitudes. And for homework, okay, I want you to find those 3 altitudes. We will do this one in class as well. So skip number 4, all right, and then practice these 3 constructions. Okay, so that's going to be your homework. And this is what we'll practice in class on Thursday and Friday. Okay, so leave these ones. We'll do number 4 in class, number 5 in class. Okay, just find the altitudes and then practice your constructions. Okay, good luck, you guys.